Have you ever wondered how something as destructive as a tornado is formed from just air and water? A tornado, a vortex of wind spiraling at terrifying speeds, is one of nature's most awe-inspiring yet destructive phenomena. It can flatten houses, uproot trees, and toss cars around like toys in its path. But how does something so formidable come into existence? The creation of a tornado is a fascinating interplay of elements and atmospheric conditions. It all starts with two key ingredients: warm, moist air near the surface and cooler, drier air above it. This combination sets the stage for a brewing storm, a crucial step in the formation of a tornado. But there's more to it than just these basic elements. The science of tornadoes involves complex mechanisms and processes that are still being studied and understood by meteorologists around the globe. In the next few minutes, we're going to unravel the mystery behind these powerful storms. To understand how a tornado forms, first we need to grasp the concept of a supercell thunderstorm. And to do that, imagine a warm, wet day. The air is thick with moisture and the sun's rays heat up the Earth's surface. This warm, moist air begins to rise, creating an updraft. Now picture a layer of cooler, drier air above this rising warm air. As the warm air ascends, it cools and condenses, forming clouds and eventually a thunderstorm. But this isn't your average garden-variety thunderstorm. This, my friends, is the birth of a supercell. What sets a supercell apart from other thunderstorms is rotation. And this rotation is sparked by wind shear, a fancy term for changes in wind speed and direction with height. Picture it like this. At the Earth's surface, the wind is slow and steady. But as you ascend, the wind picks up speed and shifts direction. This disparity creates a rolling effect in the air, a bit like a horizontal spinning tube. Now imagine our updraft lifting this spinning tube of air into a vertical position. Suddenly, you've got a rotating column of air within the thunderstorm. This is our mesocyclone, the heart of a supercell storm. As the mesocyclone strengthens, it creates an environment ripe for severe weather. Torrential rain, large hail, lightning, and yes, potentially tornadoes can all spring from this swirling beast. The stronger the mesocyclone, the higher the chance for extreme weather, but it's important to note that not all supercells spawn tornadoes. In fact, most don't. The conditions have to be just right. The atmospheric instability, the moisture, the wind shear, it all has to align perfectly. It's almost like baking a cake. If you miss one ingredient or misjudge the timing, you won't get the desired result. So we've got a rotating thunderstorm, but how does this become a tornado? Well, stay tuned, because the birth of a tornado is a tale of atmospheric drama that you won't want to miss. From a rotating thunderstorm to a tornado, the transition is a fascinating process. The evolution of a tornado begins with a simple yet powerful rotating column of air known as a vortex. This vortex is an integral part of the thunderstorm, serving as the spine of the storm's structure. The process of tornado formation is a spectacular dance of physics and meteorology, as the thunderstorm's updraft plays a pivotal role. The updraft, a rising current of warm, moist air, begins to stretch the vortex vertically. This stretching has two significant effects on the vortex. Firstly, as the vortex is stretched vertically, its diameter decreases. Think of it like a figure skater pulling in their arms during a spin. As the arms come in, the skater spins faster. This is due to the conservation of angular momentum, a principle that governs the movement of rotating bodies. Similarly, when the vortex's diameter shrinks, it naturally begins to spin faster. Secondly, as the vortex's speed increases, the air pressure inside it decreases. This is in accordance with Bernoulli's principle, which states that an increase in the speed of a fluid occurs simultaneously with a decrease in its pressure. In the case of our vortex, the faster it spins, the lower the pressure within it becomes. The low pressure inside the vortex creates a suction effect, drawing more air, and occasionally debris, into the vortex. This fuels the vortex, allowing it to grow in strength and size. As the vortex continues to stretch, spin faster, and suck in more air, the rotating column of air gradually takes the form of a visible funnel cloud. As this funnel cloud touches the ground, a tornado is officially formed. This transformation from a simple column of air to a fearsome force of nature is a testament to the power and complexity of our planet's weather systems. And there you have it, a tornado is born. But how does it work? This is where the real intrigue begins, as we delve deeper into the inner workings of these mesmerizing meteorological phenomena. Now that we've seen how a tornado is formed, let's delve into the mechanics of this destructive force. A tornado in its essence is a violently rotating column of air. But what keeps it swirling and moving? The answer lies in the interplay of three main elements: the central downdraft, the surrounding updraft, and the debris cloud. The central downdraft is the heart of the tornado. It's a powerful gust of cool, dense air that cascades down the center of the tornado. As it descends, it pulls the surrounding air down with it, creating a spiraling motion. This is what gives the tornado its characteristic spin. The second element, the surrounding updraft, is just as crucial. As the downdraft pulls air down, the updraft draws in warm, moist air from the sides and lifts it upwards. This constant cycle of rising and falling air forms the tornado's vortex and sustains its rotation. The greater the difference in temperature and humidity between the updraft and downdraft, the more intense the tornado becomes. Lastly, we have the debris cloud. This is the cloud of dust and debris that's often seen swirling around the base of the tornado. It's not just an ominous visual effect, it plays a vital role in the tornado's mechanics. The debris cloud feeds the tornado with additional warm, moist air, which strengthens the updraft and intensifies the tornado even further. These three elements, working in unison, create a self-sustaining engine of destruction. The central downdraft provides the spin, the updraft fuels the tornado with energy, and the debris cloud amplifies its power. However, it's important to remember that although tornadoes are destructive, they are also marvels of nature. They are a testament to the incredible power and complexity of our atmosphere. By understanding the mechanics of a tornado, we can better predict when and where they will occur and prepare ourselves accordingly. Tornadoes are not just destructive, they're complex, fascinating phenomena of nature. Understanding them helps us better predict and prepare for their occurrence.